On the 12th of July 2022, the James Webb Space Telescope in orbit around Earth took these images. The billion-dollar telescope captured the most distant galaxies in our universe, the farthest one being 13 billion light-years away from us. But did you ever wonder why we measure distances in space with light-years instead of miles, or more appropriately for NASA, kilometers? Most of us heard about the speed of light. Contrary to what we might think, when we turn on the lights in our room, light doesn't just instantaneously appear. Light is a substance just like any other. Well, maybe not just like any other, but it still has to travel from the light bulb in our dark room, hit the walls and furniture in the room, and then bounce from them and enter our eyes. This takes time. Not any amount of time we could notice. It will take about 3 nanoseconds for light to, enlighten your room and arrive into your eyes, where your brain will then form the image of the room using the information from those light particles. It takes light 8 minutes to travel from our sun to us on Earth. This means that the image of our sun in the sky is not how the sun looks right now. It's how the sun looked 8 minutes in the past when that light from the sun departed and started traveling to us on Earth. Our moon? It's closer. It takes only a little over 1 second for the moon's light to reach us. So what if there was a gigantic explosion on our sun, or if the sun just had a catastrophic failure and went black? Well, we would have no way of knowing it for 8 minutes, the time it would take for the light from that explosion, or lack of light from it going black, to reach us. And now we come to the James Webb Telescope pictures. The light from these galaxies traveled for 13 billion years to reach Earth. We are not simply seeing deep into space and looking at galaxies in the present. We are looking at galaxies in the distant past. Many of these galaxies we see could have already died out, naturally burning away, or could have changed drastically in shape, color, crashed into one another to form greater galaxies, or shattered into many smaller ones. For all we know, they could have been consumed by aliens as a building material to make galactic-sized constructions. So now we should ask ourselves, is this the oldest photograph in the world? Or is this? This is a primitive early picture of Paris in 1838. It is the oldest proper photography in the world, except this picture you are seeing is about 200 years old. This picture is 13 billion years old. So, which is the older one? It's interesting to think about the limitations of science. Instead of a straight border, its limits vary wildly, perhaps the most extremely of anything we know of. We have no photographs of Napoleon, who was alive 200 years ago and left a huge mark on world history. We have no photographs, and probably never will, of the pyramids being built or the dinosaurs. Yet we have photographs of things 13 billion years in the past. These galaxies. Another paradox in our knowledge is that we know, for instance, the temperature of long-gone oceans. We know that 3.5 billion years ago, our Earth's oceans were 150 Fahrenheit or 80 Celsius. Pretty hot. Yet we still don't know what color were the dinosaurs. Sure, we make them green or brown in our movies, but for all we know, real dinosaurs might have been pink or even purple. They might have been red with yellow dots. We just don't know. We haven't figured out how to deduce color from dinosaur bones and other remains. However, we do know the color of galaxies that existed 13 billion years ago which we never visited, which are over 200 times older than dinosaurs. And unlike dinosaur bones, their remains aren't even on Earth, where we can chemically analyze them in laboratories. We can even tell the chemical composition of distant stars. For example, although we never left our solar system, we know that our closest star, Alpha Centauri, contains magnesium, silicon, and iron. We know this from the type of light and radiation it produces, which is then picked up by our radio telescopes and analyzed to determine which chemical materials would be necessary to produce such waves. As a parting thought, if you support space exploration and would like to help humanity reach for the stars, you can consider volunteering your time at zooniverse.org. Zooniverse is not a sponsor of this video. This is just a shout out from a well-wisher who supports their work. They are a website which links average anonymous internet users with thousands of images from radio telescopes and other instruments that need to be catalogized in a way anybody can do. The cataloging is given to several anonymous users in parallel to recheck it and ensure any individual catalogization someone made wasn't a fluke. Zooniverse.org has already made several discoveries in the real world. It has published scientific papers and has even discovered thousands of new exoplanets, all with the help of ordinary volunteers like you. There is no training necessary, and you can catalog for as long as you like. You can go on for hours or just do one picture and stop. If you are looking for something productive to do with a bit of time you have while listening to podcasts or relaxing, consider zooniverse.org. You can see many pictures of galaxies millions of years in the past, similar to the ones made by the James Webb Telescope. Except these will be galaxies that almost no human eye has ever seen. It is an impactful, easy, and accessible way you personally can help humanity make new scientific discoveries and bring us closer to the true space age.